Hey guys, this is Saurav here and welcome to another session for the KVPY SX program. This is lecture 5 and this will deal with GOC and a few parts of isomerism. This is the starting lecture for organic chemistry. We would have 3 more lectures for organic chemistry, and it is important that you do a proper revision of GOC before you go and write your KVPY examination. The reason is GOC is the fundamental, the basic, and इसके ऊपर questions काफ़ी सारे आते हैं, okay? And GOC easy होता है. GOC और isomerism में बहुत ज़्यादा complicated चीज़ें नहीं पूछता है KVPY. They ask very easy stuff. So if you find that the questions are easy today, then don't get very happy, because KVPY does ask slightly challenging questions in organic chemistry. We will see those questions in the forthcoming sessions. So I'm very sorry I couldn't record a video earlier because my throat was not my throat was not giving any support to me. Okay, so आज मैं थोड़ा ठीक हूँ. So let's discuss few questions on GOC and physical and chemical properties of organic chemistry, starting of the organic chemistry series. So आज की सेशन में हम अपना सेशन स्टार्ट करेंगे फर्स्ट क्वेश्चन से, बट बिफोर दैट दिस इज द फ्लो ऑफ टॉपिक्स. सो 5 सितंबर का ये सेशन था, GOC, chemical and physical properties, and after that we have 3 more sessions lined up for organic chemistry. Okay, so please don't get worried. Always remember, we are always here with you to discuss as many things as possible. और आप देख रहे हैं कि लास्ट वाला सेशन जो है that is on revision and doubts. So it will be a wholesome program. Please do pass on the word to your friends and other people that you know that we are conducting this amazing series. Okay, so let's start today's session with the first question, which is this: the order of acidity of the following compounds 1 to 4 is 1 2 3 4. We have benzyl alcohol, इसको बोलते हैं benzyl alcohol, benzoic acid, this is paracresol, and this is benzene sulfonic acid. How do we judge acidic strength? Remember, acidic strength is judged by the stability of the conjugate base. So I'll just write over here, the method is acidic strength is proportional to stability of conjugate base. What is conjugate base? An entity which is formed by removal of just one proton from the given compound. So you remove which proton? The most acidic proton, जो कि सबसे electronegative element के साथ लगा है. You cannot remove a proton from CH3 because that's not the most electronegative element. The most electronegative element is oxygen. Most electronegative element is oxygen. Most electronegative is oxygen. Most electronegative is oxygen. So you remove the proton attached to the most electronegative element and check the stability of the conjugate base. Whatever an ion is generated, you check that stability. इसकी stability अगर ज़्यादा होती है, then the tendency to behave as an acid will be higher, because if the stability of the conjugate base is more, then the tendency to retake the H plus ion is less. एक acid water में dissociate कर रहा है and it is giving out H plus ion and the anion simultaneously. Now the anion will try to take up H plus, लेकिन अगर anion stable हो गया तो H plus को लेने की कोशिश नहीं करेगा, and if it does not try to take up H plus, then the amount of H plus present in the medium would be higher compared to a situation जहाँ पे anion की H plus को लेने की tendency ज़्यादा है. The tendency of anion to take up H plus will completely depend on its stability. If stability is high, then its tendency to take up H plus is less. Medium has more H plus, that means the acid turns out to be a stronger acid. Okay? So with that, let's try to identify what are the conjugate bases. So fourth का जो conjugate base होगा, that will be like this. This is sulfonate ion, benzene sulfonate ion. Seconds, the conjugate base for this one would be The conjugate base for this one would be and the conjugate base for this would be, बहुत easy है, you remove a proton from OH and you obtain this. Okay, now what makes an ion stable? Few factors जो कि हमने पहले पढ़े हैं, that is one of them is aromaticity, resonance, hyperconjugation. Now aromaticity is the most favorable factor, but though the ring is aromatic, यहाँ पे जो ring है ये aromatic है, but क्या ये ion के बनने के कारण वो aromatic हो रहा है? नहीं. Try and understand this. Your father or your mom may be well accomplished in their career. They might be occupying high positions of power in the society. But does that automatically make you equally influential? No. Okay. So you have to prove your merit. So is the ion becoming aromatic? No. The ring was already aromatic. So यहाँ भी aromatic है, यहाँ भी aromatic. हमको ये नहीं देखना है. हमें देखना है कि in which case resonance is taking place and in which case resonance is not taking place. जहाँ पे resonance हो रहा है, wherever resonance is occurring, that ion will become more stable. So can we identify an ion in which resonance is not at all taking place? This is the ion in which resonance is not at all occurring. So first वाले केस में resonance बिल्कुल भी नहीं है, and so first का this is the conjugate base produced from this compound. So this compound will become the weakest acid. So 1 should be the weakest acid. We have only one option. Answer A होना चाहिए. But let's try to identify that why 4th would be the strongest acid. Now if I look at O minus, this O minus is conjugated with this. It is also conjugated with this. Now all of these resonating structures are equivalent. यहाँ पे भी resonating structures equivalent है, but over here resonating structures are non-equivalent. Equivalent resonating structures means when you draw the resonating structures, whatever is formed looks structurally alike when compared to the previous one. For example, इसका जो resonating structure बनाएंगे हम, वो कुछ इस तरह का बनेगा. SO minus. This is the resonating structure. There is no difference between this as well as this. All oxygens are alike. तो आप negative charge यहाँ लगाओ या negative charge यहाँ लगाओ, कोई फर्क नहीं पड़ता है. But in this case, the negative charge, can you see that the resonating structure looks different from the original structure? So these two resonating structures are non-alike. These two resonating structures are alike. This resonating structure will give rise to another resonating structure which will be alike. Now the point is, अगर आपके पास alike resonating structures मिल रहे हैं, then that imparts way more stability than number of resonating structures. So यहाँ पे number of resonating structures आपके पास 1, 2, 3 मिल जाएगा, यहाँ पे 2 मिलेगा, but यहाँ पे 3 equivalent है, यहाँ 2 equivalent है, यहाँ पे all of them are non-equivalent. So equivalent imparts more stability compared to number of resonating structures. So this will be most stable anion, followed by this one, followed by this one. So 4, उसके बाद 2, उसके बाद 3, उसके बाद 1. Okay, now please don't say that कि सर यहाँ जो resonance हो रहा है उसको हम क्यों नहीं देख रहे हैं, क्योंकि ये जो resonance हो रहा है, this resonance is not, or these bonds are not in resonance with the negative charge. I have to check the resonance of the negative charge. ठीक है? Clear? So आगे चलते हैं. Let's take the next question. The next question is this. The enantiomeric pair among the following 4 structures is. Now what is the meaning of enantiomeric pair? The configuration about the chiral center would be different. Now enantiomers would be pronounced in optical isomerism का part है, and isomerism में सबसे पहली point ये रहती है कि that the molecular formula should be alike. Okay, the molecular formula should be alike. Now first and foremost, let's look at where do we have chiral center. देखिए wedge और dash अगर मैंने कहीं भी बना दिया, इसका मतलब ये नहीं है कि वो chiral हो गया. If I draw wedge and dash anywhere, that does not mean that it is chiral. Look at the groups. There is OH, H, methyl, and this whole group is propyl. This is OH, H, H, and this is butyl. Now the thing is, at a tetrahedral center, this is a tetrahedral center because the hybridization is sp3. So at a tetrahedral center, if there are 4 different groups attached, then it will turn out to be chiral. Then that center would be known as a chiral center. Okay, so ये chiral center नहीं है. This is a chiral center. यहाँ पे chiral center क्यों नहीं है? Because these two are hydrogen atoms. Though these hydrogen atoms are shown by wedge and dash, but showing by wedge and dash does not bring chirality. Having 4 different groups brings chirality. So this is chiral. This is obviously not chiral. This is chiral. Now what we can see over here is OH is shown by a wedge bond. This is a wedge bond. OH is shown by a dashed bond. Okay, OH is shown by a dashed bond. So if OH is shown by a wedge bond, OH is shown by a dashed bond, the configuration would be different. If the configuration would be different, हम करते क्या है इसको? If I look at this molecule, then it seems like hydrogen is away from the observer and OH is towards the observer. In this case, OH is away from the observer and hydrogen looks like it is towards the observer. So there is complete difference in configurations. So 1 and 4 would be enantiomers of each other. The right answer should be B. 1 and 4 should be enantiomers of each other. Clear? Chali. Let's go on to the next question. The next question is this. It's very easy. The most stable conformation for N-butane. Most stable conformation for N-butane. Okay. How do we solve this? देखिए, N-butane looks like this. This is N-butane. CH3, CH2, CH2, CH3. Okay, ये है हमारा N-butane molecule. Now, if I look around carbon number 2 and carbon number 3, if I look at the carbon-carbon bond at carbon number 2 and carbon number 3, can I say that carbon number 2 and carbon number 3 contain one methyl, one hydrogen, one hydrogen. This contains one hydrogen, one hydrogen, one methyl. Okay. Now, assume that you are looking along this axis. कार्बन कार्बन की तरफ से देख रहे हो. So doesn't this look like a inverted Y? Doesn't this look like an inverted Y? Inverted Y के जैसा है. This also looks like an inverted Y. So it is quite possible that the inverted Y at the front carbon, let's say this is the front carbon and this is the rear carbon, पीछे वाला carbon है. So the inverted Y in the front carbon and inverted Y in the rear carbon have identical groups behind each other. हो सकता है? So it means, इसको दिखाने का तरीका क्या होता है? We draw a circle and we draw an inverted Y. Group is MEH. रियर वाले को कैसे दिखाएंगे? MEH. Okay. So what you can see over here is that I can show a representation in which the inverted Y has same groups behind each other. This is known as eclipsed. It is completely eclipsed. Methyl is behind methyl, hydrogen is behind hydrogen, this hydrogen is behind hydrogen. So if I'm looking from here, I would not be able to see this, this and this. हमें सिर्फ सामने वाले ग्रुप्स दिखेंगे, पीछे वाले ग्रुप्स नहीं दिखेंगे, because that is completely eclipsed. Okay? Now, conformations are shown for single bonded molecules because single bonded molecules can rotate about the single bond. Okay, single bond के about आप rotate कर सकते हो. So they can rotate by infinite number of angles, but we take only those angles which are in multiples of 60 degrees. So if I keep the front carbon like this, जैसा है वैसे ही रहने देते हैं, and rear carbon को थोड़ा rotate करते हैं 60 degree से clockwise direction में, then I will be getting MEH MEH. Okay, I'll be getting this. देख लीजिए. Now there is some distance between the two methyl groups, and so this arrangement is slightly more stable than this one. So this is known as gauche. This is known as gauche. Now the point is, what would be the most stable conformation? इनको बोलते हैं conformations. What would be the most stable conformations? The most stable conformation would be one in which methyl and methyl are farthest from each other because they can encounter some repulsive interactions. Okay, they can have some repulsive interactions between each other. So if I place them farthest from each other, so the farthest placing them farthest would require that they should be at an angle of 180 degrees. So in which case we have 180 degrees between the two methyl groups. This, so the right answer should be A. Okay, the right answer should be A. Okay, chaliye. Next question. The aromatic carbocation among the following. How do we judge aromaticity? Aromaticity is judged using Huckel's rules. Huckel's rules, there are certain rules which are very important. First rule that the molecules should fulfill is that it should be cyclic. Open chain molecules are not aromatic. Cyclic molecules are aromatic. So पहला चीज, अगर आपको देखना है कि molecule aromatic है या नहीं, तो पहले ये देखो कि वो cyclic है या नहीं. If it is cyclic, then okay, चलो एक criteria तो fulfill हो गया. One criteria is fulfilled. Next, planar. What does planar mean? All carbon atoms or all atoms of the ring should be sp2 hybridized. All atoms of the ring should be sp2 hybridized. Third, conjugation. There should be complete conjugation within the ring. That means all atoms should be conjugated with each other, or all atoms should be involved in conjugation. इन सारे atoms के ऊपर pi electrons का movement होना चाहिए. Okay, ऐसा नहीं कि आपने there 5 carbon atoms आपने 4 के ऊपर movement कराया and 5th is not participating in conjugation, और 5th carbon atom के ऊपर you are not placing double bonds alternating times. That is not gonna happen, or that is not gonna fulfill the criteria for conjugation. Conjugation means complete conjugation. Complete conjugation. And fourth, which is the most vital one, there should be 4n plus 2 pi electrons. Whatsoever electrons are moving within the ring, they are all counted as pi electrons. ओके ये इलेक्ट्रॉन्स पाई बॉन्ड्स में भी रह सकते हैं और ये इलेक्ट्रॉन्स नेगेटिव चार्ज से भी आ सकते हैं, एंड दीज इलेक्ट्रॉन्स कैन आल्सो बी कैन आल्सो कम एज लोन पेयर्स. ओके, सो once they start conjugation, all of them convert into pi electrons. ठीक है, सो रिंग के अंदर कोई भी इलेक्ट्रॉन कॉन्जुगेशन कर रहा है, चाहे वो वेदर इट हैज कम फ्रॉम double bond, whether it has come from lone pair, whether it has come from a negative charge, all would be counted as pi electrons. N can be 0, 1, 2, so on and so forth. Okay, so let's take this. All atoms cyclic, this is cyclic. All atoms are sp2 hybridized. All atoms involved in conjugation, this is so this double bond is conjugated with this, so these three atoms involved, this double bond is conjugated with this involved. तो पहले तीन क्राइटेरिया तो फुलफिल हो गए. लास्ट क्राइटेरिया क्या है? How many pi electrons do we have? Positive charge does not account for any electron, so they have 2 pi bonds that you can see, so there are a total of 4 pi electrons. 4 pi electrons. Does it fulfill this rule? No. Remember, if the first 3 rules are fulfilled and the last rule is, and when you evaluate the number of pi electrons, and you get 4n pi electrons. If you get 4n pi electrons, first 3 rules are same for if a compound fulfills the first 3 rules, but the number of pi electrons can be expressed as 4n pi, where n is 1, 2, 3, so on and so forth. Then this is known as anti-aromatic. It is known as anti-aromatic. Anti-aromatic species are highly unstable, and if you compare the stability of anti-aromatic with aromatic and non-aromatic, then सबसे ज़्यादा stable हो जाएगा aromatic, followed by non-aromatic, and the least stable would be anti-aromatic. Okay? So this is anti-aromatic. अब देखो ये वाला चीज़ साइक्लिक तो है, फर्स्ट रूल तो फुलफिल हो गया. प्लेनर, आर ऑल पॉइंट्स इन्वॉल्व इन कॉन्जुगेशन? नो, दिस पॉइंट इज लेफ्ट आउट, सो हम इसको कंसिडर ही नहीं करेंगे. लेट्स टेक दिस वन. साइक्लिक, प्लेनर, आर ऑल पॉइंट्स इन्वॉल्व इन कॉन्जुगेशन? नो. व्हाट अबाउट दिस वन? Cyclic, all points involved in conjugation? Yes. Planar, all points are sp2 hybridized. Number of pi electrons is 6 pi electrons, which makes it aromatic. So C is the right answer. Okay, C will be the right answer. Chaliye. An organic compound having a molecular formula C2H6O on oxidation with dichromate in presence of H2SO4 produces X, which contains 40% of carbon, 6.7% hydrogen, and 53.3% oxygen. The molecular formula of the compound is. Now to solve this question, there are 2 methods. One method is that you identify the empirical formula of the product using the percentages. But वो लंबा method है. Okay, that's a lengthy method because you have to calculate empirical formula, and calculating empirical formula involves maths. क्यों empirical formula calculation करना है? Let's try to identify if we can do it some other way or not. सबसे पहला काम ये करो कि whenever such question is given, you try to calculate a degree of unsaturation. Now, degree of unsaturation for this compound will be calculated using the formula degree of unsaturation using the formula 2C minus H plus 2 upon 2. Degree of unsaturation will always have this formula. Degree of unsaturation tells us that how many double bonds or rings are present within the molecular compound. So 2C, how many carbon atoms are there? 2. So I will write 4. Number of hydrogen atoms 6 plus 2 by 2. The value comes as to be equal to 0. Okay, the value comes as to be equal to 0. Now, if the degree of unsaturation is 0, it means, if degree of unsaturation is 0, it means only sigma bonds. Only sigma bonds and open chain. So, if I look at the molecule, it should have only sigma bonds and it should have an open chain structure. That is signified by degree of unsaturation value 0. If degree of unsaturation value is 1, अगर ये degree of unsaturation 1 हो गया, इसका मतलब ये होगा कि कंपाउंड में आइदर एक डबल बॉन्ड है, आइदर वन डबल बॉन्ड और वन रिंग. ओके, अगर टू हो गया देन इट विल बी आइदर वन ट्रिपल बॉन्ड और टू डबल बॉन्ड्स और टू रिंग्स और वन डबल बॉन्ड एंड वन रिंग. इतने सारी पॉसिबिलिटीज हो जाएंगी. नाउ व्हेन इट इज जीरो, इट इज वेरी सिंपल. इफ इट इज जीरो and it is an oxygen containing compound, it means it could either be an ether or an alcohol. ठीक है? So I'm just erasing this part. Presence of oxygen does not play any role over here. Degree of unsaturation formula will remain unaffected if there is oxygen. Okay? So C2H6O is a molecule which contains sigma bonds and is a open chain, has open chain structure. So it could either be an alcohol or an ether. It cannot be aldehyde, it cannot be ketone क्योंकि वहां पे एक minimum double bond तो present है. Okay? But it is giving us a value of degree of unsaturation which is 0. So it is alcohol or ether. It cannot be ether because ethers do not get oxidized with dichromate in presence of H2SO4. Okay, so it has to be an alcohol. And what kind of an alcohol should it be? CH3, CH2OH. It has to be this alcohol. Okay, now dichromate in H2SO4. Dichromate in H2SO4 behaves as a strong oxidizing agent and will oxidize alcohols to carboxylic acids. Okay, it will oxidize alcohols to carboxylic acids. So carboxylic acid agar hua, then the formula will turn out to be CH3COOH. This carbon will get oxidized and we will get this molecule. If this molecule is obtained, it has to be C2H4O2. The only possibility is B. It cannot be C2H6O2 क्योंकि oxidation में hydrogen निकल जाता है. Okay, can you see that the number of hydrogen has reduced? So it is important to know that dichromate is a strong oxidizing agent. आपको हमेशा carboxylic acid मिलेगा from alcohols. Clear? So with this, let's move on to the next question. The next question is this. The maximum number of cyclic isomers, position and optical possible for a compound with molecular formula C3H2Cl2 is. Okay? Isomerism में हमेशा थोड़ी थोड़ी दिक्कत आ जाती है. तो C3H2Cl2, can you calculate the degree of unsaturation? अब देखो यहाँ पे 2 क्लोरीन आ गया है. ठीक है? Whenever you see 2 chlorine or whenever you see a halogen, डिग्री ऑफ अनसैचुरेशन फॉर्मूला को इस तरह से मॉडिफाई करोगे दैट फॉर एवरी हैलोजन यू विल ऐड 1 हाइड्रोजन. ओके, फॉर एवरी हैलोजन यू विल ऐड 1 हाइड्रोजन. सो प्लस 2 हाइड्रोजन. सो आवर डिग्री ऑफ अनसैचुरेशन फॉर दिस विल बिकम 2C minus H plus 2 upon 2, which will further be written as carbon number is there are 3 carbon atoms, so it is 6 minus hydrogen. Total hydrogen will become 4 plus 2 by 2. 8 minus 4. 4 by 2, that is 2. Degree of unsaturation is 2. So it should have either 2 double bonds या फिर 2 रिंग होने चाहिए या फिर एक डबल बॉन्ड या एक रिंग हो सकता है. ओके, पिछले क्वेश्चन में हमने देखा if degree of unsaturation is 2, it can be 2 double bonds or 2 rings or 1 ring and 1 double bond. लेकिन there's 3 carbon atoms, तो 3 carbon atom के कितने rings बन सकते हैं? The max 1 ring बन सकता है, एक double bonds हो सकता है, but you cannot have 2 rings over here. So 2 rings वाला possibility हट जाता है. So what we can do is C3H2Cl2 can be drawn like this. This can be This can be one structure for C3H2Cl2. C3H2Cl2. Another structure for C3H2Cl2. Position on optical बताना है. So another structure could be this. I can have one Cl over here and one Cl over here. Okay, and another structure could be this. Clear? The two hydrogen atoms over here. Perfect. हो गया. अब एक बात बताइए, हमें ऑप्टिकल बताना है, तो ऑप्टिकल के लिए मुझे क्या चाहिए? कायरल सेंटर. एंड कायरल सेंटर कैसे हम खोजेंगे? आई विल लुक फॉर एन asymmetric carbon, one carbon atom where the four groups are different. So can we identify a chiral center? Yes, we can. This is a chiral center. Cl, इधर में C लगा हुआ है, यहाँ पे CH लगा हुआ है. So this is a chiral center. The groups attached, 4 groups, यहाँ पे एक हाइड्रोजन भी है. So 4 groups attached at this carbon atom are different. So if whenever there is a chiral center, its enantiomer will also be a part of the assessment. Okay, so when you count, you will also count its enantiomer. So one chiral center, so one more, total of 2 optical isomers, this plus its enantiomer. So answer कितना हो जाएगा? 1, 2, 3 and 1, 4. The right answer should be C. The right answer should be 4. Clear? हमें पूछा गया था positional and optical. So position optical मिला के बताना है. So all of these look like position. We are changing the position, and which is optical? This one is showing optical activity. ठीक है? चलो. Next, the number of stereoisomers possible for the following compound. The first and foremost, you need to know that stereoisomers and chiral optical isomers are not alike. Okay, a lot of times people make this mistake by judging both of them to be the same. Stereoisomers and optical isomers have slight difference, that all stereoisomers are not optical isomers, but all optical isomers are stereoisomers. Let's try and understand this statement. So stereoisomerism जो होती है, isomerism is divided into 2 parts, geometrical and optical. A compound which is capable of showing geometrical isomerism will also be exhibiting stereoisomerism. ठीक है? एक कंपाउंड जो कि geometrical isomerism शो कर रहा है will also be showing stereoisomerism. A compound which is showing optical isomerism will also be showing stereoisomerism, but सारे कंपाउंड जो stereoisomerism शो कर रहे हैं, they are not exclusively optical. That is what my point was. Okay, so if you have understood this, let's try and understand कि यहाँ पे कितने stereoisomers बनेंगे. Now geometrical isomerism कहाँ पे होगा? Geometrical isomerism cis trans हो सकता है, EZ हो सकता है, ये आप जानते हैं कैसे करना है. So if there is a carbon and there's a double bond, so let's say this is the molecule. So what I will do is I will take an axis like this. I will take an axis like this. I'll take an axis like this. I will fix one part of the molecule. इस part को मैं fix कर दूंगा. Okay, let's say we fix this part. When we fix this part, and we hypothetically in our mind, hypothetically only, I rotate this carbon. So I fix this part and rotate this part. What do we obtain? We obtain something like this. This part is fixed, so no changes over here in the way A and B are arranged. But if I rotate the other part by 180 degrees, I will get AB. Do they look different? Do they look different? Yes. If they look different and it is about a double bond, that means they would be showing geometrical isomerism. Okay? And this will be known as one stereo center. This will be labeled as one, एक डबल बॉन्ड को हम एक स्टीरियो सेंटर बोलेंगे. सो जहां भी ज्योमेट्रिकल आइसोमेरिज्म होती है वहां पर हम स्टीरियो सेंटर्स आइडेंटिफाई कर सकते हैं. एक डबल बॉन्ड को हम स्टीरियो सेंटर बोलेंगे ओनली इफ इट शोज चेंज while we do this operation. This is the hypothetical operation just to identify that whether this double bond will show optical activity or not. एक simple question ले सकते हैं कि अगर हमने यहाँ पे मिथाइल कर दिया and I put hydrogen over here and I put hydrogen over here and let's say I put hydrogen over here and I ask you that whether this will show geometrical isomerism. So what you do is you do the same operation and you would still be getting something like this. Is there any difference? No. So this molecule will not show geometrical isomerism. But over here, this part will show geometrical, and this carbon is chiral. You can see it is attached to BRH, this whole group and this whole group. All of them are different from each other. So this is a chiral center. So this is geometrical this center is a stereo center. This is one another stereo center. दो stereo centers हैं. So total number of products formed would be number of stereoisomers possible would be 4. Because एक simple idea ये देख लो कि we label optical chiral centers as R or S. ठीक है? R or S या D or L आप ले सकते हैं. This can be cis or trans. So cis, trans, cis, trans. So it is possible that when it is cis, this is R. When this is trans, this is R. When this is cis, this is S. When this is trans, this is S. So we have a total of 4 combinations. So total number of stereoisomers will be 4. Clear? Let's move on to the next question. This again a similar question. Number of stereoisomers. Similar question hai. This will show geometrical isomerism and this will show chiral. This is a chiral center. So this is a chiral center and this will show geometrical isomerism. Answer over here will also be 4. Clear? Chalo. Next, among the following, how many of them are anti-aromatic? Okay, you have to identify anti-aromatic. That means all features should be fulfilled except for the number of pi electrons. Number of pi electrons should be 4 and pi. When you look at this molecule, okay, these molecules are known as azulenes and these molecules will exhibit aromaticity in such a manner that ये double bond इधर आता है and this will come over here. It will generate a structure like this. Generate a structure like this. Both the rings are aromatic. This ring, ये total number of pi electrons कितने हो गए? 2, 4, 6, 6 pi electrons in this ring. Similarly, this negative charge will be involved in delocalization with these 4 pi electrons. So 4 pi electrons plus 2, 6. This pi electron is common. Okay. So this is aromatic. Okay. This is non-aromatic. Okay. If I break this double bond, what will happen? I will get something like this. I'll get something like this. You can see 4 4, no pi electron, so 2 plus 2, total of 4 pi electron over here. This part will become anti-aromatic. This part will become anti-aromatic, and fifth one will be also anti-aromatic. Total number of pi electrons in conjugation is how much? 4. So this is, so third and fifth should be anti-aromatic. B, third and fifth should be anti-aromatic. Next question. In an electrophilic aromatic substitution reaction of chlorobenzene, the orthopara directing ability of chlorine is due to. आपने अगर ये रिएक्शन देखा नहीं है पहले, so this reaction takes place like this. This is our aromatic system. And ये एक इलेक्ट्रोफाइल के साथ रिएक्शन करता है. Okay? Aromatic molecules are rich in electrons, so they would not want a nucleophile approach them. Okay, attraction for a reaction to take place, there should be attraction. This is electron rich, this is electron deficient, there would be attraction, electrophile will come over here. But electrophile will not get added completely and perform addition reaction, it will rather perform substitution reaction, because अगर addition करेगा तो ये double bond गायब, addition will take place across double bond, and double bond will be lost and it will become non-aromatic. So aromatic to non-aromatic conversion is not favorable. Okay, molecule would not want to lose aromaticity, so the outcome would be something like this. तो आप देख रहे हैं, आपने एक इलेक्ट्रोफाइल लेके एक H plus जो कि इलेक्ट्रोफाइल है, you have substituted it. You have substituted a H plus which is an electrophile by using an electrophile. Now, if you attach any group over here, let's say a group like chlorine over here, and now if you want to check where electrophile will go, so now there are 3 positions available. 1, 2, 3. 3 positions which are available. Okay, जैसे कि डाइनिंग टेबल के अबाउट the dad is sitting, so you would sit as close as or as away from him depending on how soon or how soon your result is going to be declared. Okay, so if your result is getting declared tomorrow, you will try to sit farthest from him so that he doesn't look at you, and रिजल्ट अगर आने में बहुत टाइम है तो हो सकता है उनके बगल में बैठ जाओगे. इसमें वैसा नहीं होता है, उतना ज़्यादा स्टेरिक फैक्टर्स नहीं लगते हैं, बट एन इलेक्ट्रोफाइल इज गोइंग टू दिस पोजीशन एंड टू दिस पोजीशन. इट इज रिटन ओवर हियर, ऑर्थो पैरा डायरेक्टिंग. दिस इज नोन एज द ऑर्थो पोजीशन, दिस इज मेटा एंड दिस इज पैरा. सो इट इज गोइंग टू ऑर्थो एंड पैरा because if I look at the ability of chlorine to donate electrons by plus R effect, then it will increase the electron density at ortho and para position with respect to the meta position. अब इसको रेजोनेंस करा के देखोगे तो यहाँ पे नेगेटिव चार्ज आएगा, यहाँ पे नेगेटिव चार्ज आएगा, and that will increase the tendency of the electrophile to go to these 2 positions. मेटा पे होता नहीं है, आप रेजोनेंस करोगे, you will not find a canonical structure in which meta will get a negative charge. Okay, so the right answer would be positive resonance effect plus R. Clear? चलिए, let's go on to the next question. Next question is this: among the following substituted pyridines, the most basic is. So remember, basic strength is enhanced if there are more nitrogen atoms. Basic strength is also enhanced if there are electron donating groups. So हमारे पास कहाँ ज़्यादा nitrogen atoms है? Where do we have more nitrogen atoms? Answer should be B. So this nitrogen atom will also act as a base. This nitrogen will also act as a base. Cl will try to withdraw electrons towards itself by minus I effect. CH3 will push electrons towards pyridine and most basic would be B. अगर मुझे order लिखने को बोला जाता, I have written it as B followed by C followed by A followed by D. This would have been my order for basic strength. But सिर्फ most basic पूछा गया था तो आंसर हमारा B ही हो जाएगा. Next is this. The order of basic strength of this, sorry, ये द नहीं होना चाहिए. In water is, again basic strength हमें निकालना है. अब देख लो NH2. All nitrogen atoms are not alike, so remember basic strength depends on the availability of nitrogen, availability of lone pair on nitrogen. If lone pair is involved in conjugation, then it is not available for donation. Okay, it is less available for donation. कहाँ पे least available है? Least available will be this. The reason is the nitrogen's lone pair are making the ring aromatic. अगर इसने अपने लोन पेयर को दे दिया किसी को, then the ring will become non-aromatic. Conversion from aromatic to non-aromatic is not favored. ठीक है? So least basic will be fourth. Okay, least basic would be fourth, and we have two such options. 4, 4. Let's try to identify which will be the most basic compound. 2 को most basic बोल रहे हैं because there is no conjugation, and so 2 2 ये तो होगा ही नहीं. 4 4. Now between pyridine and between aniline, which is more basic? It is pyridine. Pyridine is more basic than aniline. The reason is इसके जो pyridine, this is pyridine's structure. Pyridine's lone pair is not involved in conjugation, while nitrogen's lone pair are involved in conjugation. Okay, so pyridine is more basic than aniline. The right answer for this question would be 2 followed by 3. Answer should be C. Okay, the right answer for this question should be C. Stability of carbocations, बहुत easy सवाल है. Carbocation stability again depends on 3 factors. First is aromaticity. Aromatic carbocations are most stable, followed by carbocations which have resonance, and third is hyperconjugation. So if I look at these carbocations, the first one is like this: CH3, C, CH3, CH3, positive. This is known as the alpha carbon. Positive के साथ जो carbon लगा है, that is known as the alpha carbon. And at this alpha carbon, how many carbon hydrogen bonds you are seeing? 3 carbon hydrogen bonds. How many such alpha carbon atoms are present? 3 alpha carbon. Each of them has 3 alpha carbon hydrogen bonds. So this has a total of 9 hyperconjugative structures. कोई resonance नहीं, सिर्फ hyperconjugation है. What about 2? Plus we have one OCH3 and we have CH3, CH3. How many alpha carbon atoms are present? 2 and total of 6 hyperconjugative structures. 6. This is alpha, this is alpha. The carbon atom which is attached to the carbon which bears positive charge is alpha. So this is carbon which is alpha, this is carbon which is alpha. यहाँ पे दोनों के पास 3 हाइड्रोजन एटम्स हैं. So total of 6 plus यहाँ पे और एक चीज हो रही है, that is resonance, which if you have missed out, it will make a mistake. Resonance हो रहा है. Lone pair, single bond, positive charge plus resonance. I will write just R. Third one, CH3, CH2, CH2, CH2. So if this carbon has a positive charge, अगर इसके ऊपर positive charge है, then this is alpha, and number of alpha carbon hydrogen is 2, so 2H. This has a positive charge. If this has a positive charge, adjacent 2 alpha carbon atoms, total of 5 hyperconjugative, which is gonna impart most stability, resonance. तो कहाँ resonance हो रहा है? Second. Most stable will be second. Then hyperconjugation में सबसे ज़्यादा hyperconjugation, where hyperconjugation is maximum, first. So 2 followed by first, followed by fourth, followed by third. The right answer should be B. Clear? So there is no difference for the first two things. First two most stable in this list. Last two में difference हो गया है. ठीक है? Next question is this. The acidity of compounds 1 to 4 in water: ethanol, acetic acid, phenol, acetonitrile. So I'll just write this. Ethanol is this, CH3CH2OH. Acetic acid is CH3OH. This is phenol. And acetonitrile, please do remember the structure. This is acetonitrile. Let's look at which will be most basic. Which will be most acidic. Acidic बताने के लिए हमें क्या करना चाहिए? We need to look for most acidic proton, which is attached to most electronegative element. ठीक है? But यहाँ पे ऑक्सीजन से ज्यादा इलेक्ट्रोनेगेटिव एलिमेंट जो नाइट्रोजन प्रेजेंट है, इट डज नॉट कंटेन हाइड्रोजन. कार्बन कंटेन्स हाइड्रोजन. सो एसिटोनाइट्राइल टर्न्स आउट टू बी द वीकेस्ट एसिड. Okay, acetonitrile will be the weakest acid. So fourth will be weakest. What will be strongest? Strongest will be this. Acetic acid, because it will produce a conjugate base which can show equivalent resonating structures. So 2 will be maximum. 3 and 1 में बस difference निकालना है. So this is phenol and this is aliphatic alcohol. Phenol will have resonance, this will not have resonance. So 2 followed by 3, 2 followed by 3, right answer should be A. So remember, when resonance is taking place in both the species, you will compare it on the basis of number of equivalent resonating structures or number of resonating structures. Number of equivalent resonating structure rule will always be favored above number of resonating structures. अगर equivalent resonating structure 2 भी मिल रहे हैं और number of resonating structure 4 मिल रहा है and all of them are non-equivalent, then equivalent will be given more preference. ठीक है? So last question is this. Among the following compounds, EZ isomerism is possible for 2-methyl-butene. So EZ system or EZ system of nomenclature is used for geometrical isomers or compounds which can show geometrical isomerism. So 2-methyl-butene, this is butene and there is Me. यहाँ भी Me है. Okay, there is one hydrogen and there is Me. Can it show geometrical isomerism? No. Fix this, rotate this. यहाँ पे हाइड्रोजन होगा, यहाँ मिथाइल होगा. Exactly the same thing. मिथाइल मिथाइल को फेस करेगा, हाइड्रोजन मिथाइल, एक मिथाइल एक मिथाइल को फेस करेगा, एक हाइड्रोजन एक मिथाइल को फेस करेगा. Exactly जो कि यहाँ पे दिख रहा है. Okay, this will not show geometrical isomerism. What about this one? 2-methyl-but-1-ene. 1-ene जनरली तो शो नहीं करते हैं. देख लेते हैं, यहाँ पे 2 हाइड्रोजन एटम्स प्रेजेंट हैं. नो, इट विल नॉट शो. 3-methyl-pent-1-ene. Okay, it will show optical isomerism because there is a chiral center. 3-methyl pent-2-ene. Okay, will it show? Yes. Will it show geometrical isomerism? I will take this, I will fix this part, and if I rotate this by 180 degrees, I will get a arrangement in which methyl and methyl will be opposite and ethyl and hydrogen will be opposite. So this represents a different arrangement of groups. So this molecule can show geometrical isomerism. The right answer for this question would be D. Okay? So with this, we finished this session. This session was basically on GOC and isomerism and few related effects. But from next class and onwards, next session onwards, we will be taking questions which are deep into organic chemistry, reactions, mechanisms. And I would request you guys to revise your organic chemistry while before you attend these lessons. Okay, please do remember that mock tests would be conducted. The lightning price for them is 1,000 rupees, and the link to subscribe to that is in the description section. Okay, so with this I take leave and I wish all of you guys a lovely day ahead. Bye bye and have a lovely time.